Hey, what's up? This is Hyunsuk Yoon, and welcome to the SEIR model tutorial with Numerus Model Builder. This tutorial series is designed to go over the models of our paper, and Krithi, my partner in making this tutorial series, and I are going to walk you through how to build these models and apply different analysis methods to these models on Numerus Model Builder. Numerus Model Builder is a cross-platform modeling software that integrates many types of modeling paradigms with a flexible scripting language that supports classroom teaching, prototyping, and parameter optimization. I'm very excited to introduce you to Numerus Model Builder with one of my all-time favorite types of models, which is disease modeling. And for our first tutorial, Krithi is going to start you off with using the basic building blocks of model compartments to build a logistic population growth model. So now I'm going to hand over the mic to Krithi, and I hope you enjoy.
Hey everyone, my name is Krithi, and I will walk you through a few of the modules in this paper. The first one will be building a logistic model. Now we're going to do that live, so let's go ahead and start. This is the platform we'll be using to build a model. Now we have a model name section, so we're going to say logistic, very creative. Now if you want to put a space bar, when I press space, it automatically gives you an underscore bar. So if you want to use that to name your models instead of how I've done it, go for it. The second section is the time. Now we currently have a time frame of 20 years that has been set. And this can be changed, of course. If I want to say 100 years, I can change that to 100, but I'm going to leave that for 20 for now, at 20 for now, for simplicity's sake. Now this represents our delta t, and currently it's not available because we're in a discrete method. Now the method of integration is needed to solve this model numerically. And we're going to use, now when I press this, we see there's different types. There's the Runge-Kutta, and then there's a Euler, which is all part of a continuous function, and then there's a discrete. Now Runge-Kutta is a set of iterative methods. The reason there's an RK2 and an RK4 is because these are higher orders of each other. So for example, they represent different stages, so RK4 is a higher method than RK2. And since we're developing a logistic model, I'm going to go with RK4. Now notice how my delta t value suddenly becomes available for me to manipulate. Now we're going to leave it at 1, but to check if delta t is small enough, you can run it with a particular delta t value, and then run it with a value half of that size to make sure you get the number to the desired number of decimal places that you want. Alright, so we've set up the basic functions of our system. Now let's go to our capsules. The thing with this system is it's very dynamic. So capsules essentially represent layers, and you can have different layers and multiple layers that are all joined to each other in this platform, and we will describe that in later videos. But for now, we're going to have a single layer to this logistic model. And as you can see, it's already taken my model name and given that as the first layer. So we're good. We don't have to name anything. We don't have to do anything. So let's go to our components now. If I click on components, here is where we actually build the model. So I'm going to look at several values. I want to look at a carrying capacity, a population, and a growth rate. So I'm going to drag a term and call this my carrying capacity. So I hit enter, then I double click and I go here and let's make this 100, let's say. Now here's a bunch of other functions. We will explain that in later videos. Great, so I have a K. Now if I click parameter set below, it says param over here. I'm going to hit R. I'm going to say 0.1 for my value, and then I'm going to hit a plus to add it in there. We'll talk about sliders later. Okay, great. Now the next thing I want to do is go back to components and now add in my population. Now I'm going to represent my population with the variable letter X and hit enter. Now states are very dynamic. Notice how when I double click, I have different options here. Now this is blocked off, and I'll show you in a second how it will be opened. If you're making a discrete model, then you want to use sequence so it adds on to the previous value. But if you were using a continuous function, then you want stock and flow. And stock and flow represents the dependent variable x, and the entire icon represents a differential equation. So now in our flow, I'm going to go ahead and put my equation. And my equation is the growth rate times the population times 1 minus that population divided by our carrying capacity. And I'm going to put an initial of 10, let's say. Oops, let's do 10. Okay. All right. Now I have K. Notice how when I do this, when I call these variables, I'm essentially automatically showing a physical representation. The system does this by itself, where it shows a physical representation of how you've called the value. So in this case, I called K, I called X, and I called R. So it's showing me that in these values. Now, since R is a parameter, it can't physically represent that as yet. All right, now when we have all this, we want this to run, but then we also want to be able to see what's going on. So we're going to go to displays and controls, and I'm going to pull up two things. You can just do one or the other, but to show the types of things this platform can do, I will pull up both. So now I'm going to say population table. All right, let's hit enter. So this is our table. I'm going to say table X to just represent that this is for our population. Now there's no content currently, and the way I want to add that is I'm going to hit a plus, and then I'm going to right click. So I'm going to hit a plus and right click here. Now, again, it automatically indicates that, hey, the table is pulling whatever function is happening in here as an output. Now I'm going to drag the same type of thing, but it's going to be a graph instead. So I'm going to say population graph, hit an enter, and I'm just keeping this in one line so that I can see it more easily. I'm going to say graph X, and I'm going to do the same thing here and say plus. So now again, it's added my value of the population, indicating that my population, whatever's being calculated in this equation, is going out into a representation over here. Awesome. So we have everything is set up. I've explained the stock and flow system. All right, so I think we're good to launch this. So what we're going to do is hit a launch, and this will take a couple seconds to load, but now that it does, let's make this a little bigger so you can see what's going on. And here we have a start time, end time, delta t value, everything basically shows up. So if you felt like you needed to change something, you don't really have to close out of this. You can go ahead and just change things right here. There's space to also write your JavaScript code here. And if we hit a run, there we go. So our table is documenting all these times, and our graph is showing that physical representation of our population's logistic growth. And there you have a logistic model in this platform.